This is 5-5 inequalities in one triangle. We're jumping right to the middle of chapter 5 before we move on to 6 and then 8. Okay, so for solving the warm-up problems, we're going to solve the following equations in inequalities. I'm just going to pause the video on this to save time, and you can check your answers when you're done. So hit play when you're ready. Hopefully you remembered about open and closed circles when graphing the inequalities, and also we did not reverse the inequality sign because our variable was on the left and we didn't multiply or divide by a negative. I'm going to do number 1 and 3 on these for you, and then I'll pause the video and fill in the answers so you can try all of them after that. So for number 1, this is an OR inequality, a compound inequality, and so we just solve each inequality. I get x is greater than 5, or add 8 to x is less than 2, divide by 2 on both sides, and x is less than 1. So my final answer is x is greater than 5, or x is less than 1. And if you graph that, I don't know if you remember from last year, we said it looked like oars on a boat, so less than 1 would be going to the left, and greater than 5 would be going to the right. And this creates 2 rays. That's the geometric figure that is represented. 2 rays on the graph. All right, and then let's look at number 3. This was an AND inequality, and so I'm looking at my variable x right there. I have to subtract 7 from both sides first to isolate. So I get negative 13 is less than negative x. Be careful of that negative. Less than or equal to 5. Now I'm dividing both sides by a negative 1. Remember, when we divide by a negative to both sides, we have to flip the inequality sign. So I'm going to get 13 is greater than x, which is greater than or equal to negative 5. I should rewrite this compound inequality because we used the formula small number is less than x less than big number. So I'm going to rewrite this as negative 5 is less than or equal to x, which is less than 13. This will make more sense when I graph my compound inequality. So negative 5 and 13. Really, this part means it's x is greater than or equal to negative 5. So that's going to the right. And less than 13 is going to the left. And so therefore, this is an intersection. It creates a segment. The figure that it creates is a segment. I'm going to do numbers 2, 4, 5, and 6 for you as well, so go ahead and pause the video and try these, and I'll provide the answers for you. Hit play when you're ready. So here are your answers for 1 through 6. Some of them are a little bit tricky. These are the more challenging types of compound inequalities. So if you need help with any of these, let me know. You can come in and get extra help. So there are 2 important theorems here. The first theorem that's important states that in triangles, the larger angle is opposite the longer side. And then, sort of like the converse of that, in a triangle, the longer side is opposite the larger angle. So what I mean by that, if you go down to example 2, if I'm looking at the largest side, which would be FH, then I know that angle G is the largest angle. So if I need to put these, oops, that was opposite. Okay, so if I need to put these in order from like small, medium, large, 17.2 is the smallest, and so angle F that's across from that would be the smallest angle. And 19.6 is the medium side length, and so angle H is the medium angle, and the blue ones I highlighted for you are the largest. So write the angles in order from smallest to greatest. It would go angle F for smallest, angle H for medium, and angle G for largest. In example B, we don't know angle R, but we can figure it out with the triangle sum theorem. So 72 plus 60 plus x equals 180, and we can calculate, we end up with 132 plus x equals 180, and so therefore x is 48 degrees. Now I can figure out the smallest side would be across from that smallest angle, so QP is the smallest side. The medium would be across from the 60, so that would be QR, and the largest would be across from 72, which is PR. So go ahead and try example A and B here. I'll pause the video so you can get your answer. So angle H, angle J, angle G, for example A, and for example B, it's side KM, LM, and KL. The triangle inequality theorem states that if you add two sides of a triangle, they need to be greater than the third side. That's what's being shown here. So if you add AB and BC, they need to be larger than AC. And that goes for all three sides. So in example 3A, 7 plus 10 needs to be greater than 19. And it already isn't. So this cannot be a triangle. And you can check your others. 10 plus 19 has to be greater than 7. That one worked. And 7 plus 19 has to be greater than 10. That one worked. But one of them did not, so this cannot be a triangle. 2.3 plus 3.1 is greater than 4.6. That's true. 3.1 plus 4.6 is greater than 2.3. That's true. And 2.3 plus 4.6 is greater than 3.1. And that's true. So yes, this can be a triangle. And my explanation is really the work for these. Okay, and the last one we would have n plus 6 plus n squared minus 1 has to be greater than 3n. And I can keep doing these, but actually I'm going to stop. I believe it'd be easier if we plugged in the 4 first. So let's do that. So if I plug in 4, I get 10, comma, 4 squared is 16 minus 1 is 15, and 3n is 12. So now I'm going to use those numbers instead. It's going to be a lot less work. 10 plus 15 is greater than 12. That's true. 15 plus 12 is greater than 10. That's true. And 10 plus 12 is greater than 15 is true. So this is a yes. You can try the now you try. Pause the video and hit play when you're ready. So you should have got yes, no, yes. The lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. So the numbers that I'm working with here are 8, 13, and we'll call that x, our third side. So we're basically going to be doing what we did before. 8 plus 13 needs to be greater than x. 8 plus x needs to be greater than 13. Or 13 plus x needs to be greater than 8. And then we solve all three of these. So 21 is greater than x. If you rewrite that so the variables first, you'd have x is less than 21. Solve the middle inequality. We get x is greater than 5. And solve the last inequality, and I end up with a negative. X is greater than negative 5. And that doesn't make sense for a side length. So what we really have is in between 5 and 21. So as an intersection, a compound inequality and inequality, we would write 5 is less than x is less than 21. So remember that comes from small number is less than x is less than big number. It's a formula we used in algebra to write out our compound inequalities. So for the now you try, it's the same idea. If we have 6, 11, and x, we're going to find the range of possible lengths for the third side. So we're going to write out all of our inequalities. 6 plus 11 is greater than x. 6 plus x is greater than 11. And 11 plus x is greater than 6. We can solve these. We get 17 is greater than x, which is really x is less than 17. Subtract 6 from both sides. We get x is greater than 5. And here's where I end up with my negative one that I'm not going to use. X is greater than negative 5. So this one's out. And we have our small number less than x less than our big number. So 5 is less than x, which is less than 17. In example 5 is the same thing. We have two of our sides. They're just given in a picture instead. We have 46, 51, and our third side would be x. So we could do 51 plus 46 is greater than x. 46 plus x is greater than 51. And x plus 51 is greater than 46. And solve each of these. We end up with 97 is greater than x, which is x is less than 97. Subtract 46 from both sides. We get x is greater than 5. Geez, a lot of these are 5. And subtract 51 from both sides, and there's my negative 1, so I can stop there. But x is greater than negative 5. We just don't need it. And so we do small number less than x less than big number. If you want to put in the miles for the unit, that's great. And for the now you try, it's the same thing again. You're going to be using the numbers 111 miles, 78 miles, and x miles. So you could do 111 plus 78 is greater than x. And solve that. You get x is less than 189. If you do that correctly, we have x plus 78 is greater than 111. So subtract 78 from both sides. You get x is greater than 33. And for our last one, you can do x plus 111 is greater than 78. And that's going to result in a negative. So you can't use that one. So it's 33 is less than x, which is less than 189. And put in your miles. And you're good.